Today, we're diving into power electronics. It's the invisible technology that pretty much runs our entire modern world. I mean, it's in everything from the phone in your pocket to the power grid itself, quietly and efficiently directing the flow of energy. So let's pull back the curtain and see how it all works.
All right, so to really get what power electronics is all about, we first have to understand the problem it was created to solve. And honestly, it's a problem you run into every single day, probably without even thinking twice about it.
I mean, seriously, have you ever stopped to think about that? Why can't you just plug your laptop straight into the wall socket? Why do we need that clunky power brick in the middle of the cord? Well, the answer to that simple question is the entire reason power electronics even exists.
Well, here's the deal. We're dealing with two totally different kinds of electricity. What comes out of the wall socket is high voltage alternating current, or AC. But almost all of our modern gadgets, with their delicate computer chips and batteries, they run on low voltage direct current, or DC. They're basically speaking different electrical languages. And if you tried to connect them directly, you'd instantly fry those circuits.
So that power adapter, that brick, that's our translator. And the technology packed inside of it, that is power electronics. It's the really elegant solution to this universal problem of getting our power to match our devices.
Okay, so here's the official textbook definition. But the words you really want to focus on are conversion, control, and efficiency. See, power electronics doesn't just swap electricity from one type to another. It shapes it, it manages it perfectly for whatever a device needs, and, this is the crucial part, it does it without wasting a ton of energy as heat.
And this wasn't always so small and neat. Before we had modern electronics, if you needed to convert power, you had to use these massive, heavy-duty things called motor generator sets. I mean, literally, an electric motor physically spinning a generator to create a different kind of electricity. It's wild. Today, we do that same job with tiny, silent little semiconductor chips with no moving parts at all. The technological leap is just incredible.
This whole revolution really kicked off back in 1956 with a device called the Thyristor. You can think of it as a really powerful electronic switch made out of silicon. And this wasn't just some minor step. It kicked off what people call the second electronics revolution. Over the next few decades, these switches just kept getting smaller, faster, and better, leading up to the 1990s with devices like the IGBT, which became the new workhorse for the entire industry.
So the big takeaway here is this. Each new generation of these devices got faster, a lot faster. We're talking about switching on and off thousands or even millions of times per second. Now, why does that matter? Well, faster switching is the absolute key to making power converters smaller, more precise, and way, way more efficient. It's exactly why your phone charger today is tiny, and one from 20 years ago was a giant brick.
Okay, so that's the why and the history. But how does this all actually work? Well, it turns out you can boil down almost all of power electronics into 4 fundamental types of converters. Let's take a look at these basic building blocks one by one.
First up, and by far the most common, is the AC to DC converter. You might also hear it called a rectifier. This is exactly what's inside your phone charger. The best way to think about it is like a one-way street for electricity. It takes that back and forth flow of AC current and forces it all to go in one single steady direction, which is DC.
And I mean, you find these things everywhere. They're in the power supplies for your computer, your printer, you name it. They're obviously what charges the batteries in your phone and your laptop. And they're even used in really heavy-duty stuff, like powering the massive DC motors that move electric trains.
All right, number 2 is basically the exact opposite of what we just talked about, the DC to AC converter, or as it's usually called, an inverter. This little guy takes the DC power that's stored in something like a battery and translates it back into the AC power that the grid and our home appliances use. It's just as important as the rectifier.
So, where do you see this in action? A huge one is solar panels. Solar panels generate DC power, right? Well, an inverter is what lets them feed all that clean energy back into the AC power grid. It's also the heart of a UPS, that backup battery that keeps your computer from shutting down in a blackout. And it's what lets an electric car use its giant battery to power regular stuff, like a coffee maker or a TV.
Our third building block is the DC to DC converter, and it's often called a chopper, which is kind of cool. Its job is super simple but absolutely vital. It just changes one level of DC voltage to another. Think of it like a really, really efficient digital gearbox for electricity, stepping the voltage up or down exactly as needed. Just think about your laptop. It doesn't run on just one voltage. It needs a whole bunch of different DC voltages for the processor, the screen, the USB ports, everything.
Well, choppers, sometimes called buck converters for stepping down or boost converters for stepping up, they handle all of that complex power regulation inside the device.
And finally, we have our fourth and final type, the A to AC converter. Now this one's a little more specialized than the others. It takes AC power of one kind and changes its frequency or voltage directly into another kind of AC power, without ever turning it into DC along the way.
So what's the killer app for this? In a word, motors. Big ones. The main use for these converters is controlling the speed of large AC motors. By precisely adjusting the frequency of the AC power you feed into a motor, you can control its speed with incredible accuracy. And that's absolutely essential for all kinds of industrial machinery, from giant fans and pumps to conveyor belts.
Okay, so we've met the four main players, the building blocks. Let's zoom back out and talk about why this technology is so profoundly important in your life, right now.
The rectifier, the inverter, the chopper, and the frequency converter. These four simple concepts, mixed and matched in countless ways, are the hidden engine of our entire technological world. They manage the flow of energy in everything, from power levels of less than a watt in your wireless earbuds to many millions of watts on the power grid.
There's a quote from the source material that just hits the nail on the head. It says, "Whatever it is that we really want to do, power electronics helps us to do it better." And that's so true. Whether we're trying to make devices more portable, our energy grid greener, or our factories more efficient, this is the core technology that makes it all possible. So that brings us to the big question. If this technology is already the invisible backbone of our world, what's next? Where do we possibly go from here?
Think about it. As our whole world continues to electrify, with more electric vehicles, more renewable energy, a smarter power grid, the demand for even better, smarter, and more efficient power electronics is just going to explode. The next really huge breakthrough might not be a new kind of car or a new solar panel, it might be the invisible power electronics inside that finally unlock their full potential. So the real question is, what new possibilities are they going to create?